In Chapter 7, we're going to be continuing our talk with quantum numbers. We only have one more quantum number left to look at, and really it's the easiest out of them all. It is the spin quantum number. Electron spin is quantized, so remember, quantized just means that there's a specific amount, and the way they figured this out was while they were studying line spectra in great detail, they discovered that the lines they thought to be were single were actually closely spaced pairs. So this shows us that the electrons in the same orbital don't have the same energy, and that has to do with the spin. So there's only two possible spin quantum numbers. There's a plus half and a minus half. So one of the electrons in the orbital will have a plus half, and the other one will have the minus half. So to show that, what we do is, here these two boxes, 1s and 2s, those represent the two orbitals. So to show the electrons with the opposite spin, we show one arrow going up and one arrow going down. So the arrow going up is the plus half spin quantum number, going down is the minus half spin quantum number. So to kind of go along with that, we're just going to talk a minute about magnetic materials. Anytime you have electrons that are unpaired in the orbital, then the material is magnetic. So like with 2s there's not a pair, right? There's only one electron. So unpaired electrons, that's what it looks like. So there's three types here. We have diamagnetic material, where the electrons spin are paired, and so there's no unpaired electrons. So it doesn't have a net magnetic field. Then there's paramagnetic, and there is unpaired electrons with these, and it contains atoms, molecules, or ions. And then ferromagnetic contains particles with unpaired electrons, so this would be like magnets. Okay, so going back to orbitals and energy. So the last time we were talking about energy, we were talking about the shell. So the shell is represented by N. And then also the subshell determines what the orbital energy is going to be. So as N increases, we get further and further away from the nucleus. And in an atom that has many electrons, the subshells are going to be on different energy levels as well. So we saw with hydrogen, with the one electron, that the subshells were on the same energy level, but with the many electrons, that's not what it looks like. So this is actually what it looks like right here. So you can see at the very bottom we have 1s, that's the lowest energy state, and then we go up to 2s, and then you can see instead of 2s and 2p being in the same energy level, 2p is a little bit higher in energy. And then we go 3s, and then 3p, 4s, and then 3d. So that gets a little weird right there. So 3d is higher in energy than 4s. So I'm going to give you some tips here a little later on how to figure out the steps in energy, because on this next slide it tells us that off-ball. So I do want you to know the off-ball principle tells us that the electrons are put into the orbitals with the lowest energy state possible. So we go from a lower energy to a higher energy, because remember, electrons are lazy. They like to occupy the lowest energy state possible. So this is how we're going to fill those orbitals. We'll start at 1s, we'll fill that orbital, go to 2s, fill that orbital, go to 2p, and then so on. And again, I'm going to give you some tips here in next few slides to show you how you know which orbital comes next. But remember that Aufbau tells us that the electrons flow from lower energy to higher energy. And the orbitals can hold a maximum of 2 electrons. So S can only hold 2 electrons. P can hold up to 6 electrons. D can hold up to 10 electrons. And F can hold up to 14 electrons.